So hello everyone, and today we will be seeing one of the problem from Geeks for Geeks. It says elements in the range. Now we are given an array ARR consisting of distinct positive integers and two integers start and end defining the range. Determine if array consists all the elements within the inclusive range start and end. Note, if the array consists all elements in the given range, return true, otherwise return false. So there is one example. This problem doesn't look as simple as it sounds, although it is under basic. But if you are not very interested with mathematics, numbers, systems, you won't find it very simple. You have start, you have end, you have an array. So within 2 and 5, whatever you can see, you will just sum them up. You will just understand whether they are present or not, and you will return true. One thing is you can use set, but the expected time complexity says, space complexity says you need to not use anything like that. So how are we going to solve this one? Well, I already have an explanation upon such kind of problems. What we can do over here is, we can filter it out what all things are stored within, or are within start and end. So if a number falls within start and end, let's take a sum of it, like 2 plus 3 plus 4 plus 5. So 2, 3, 4, 5. If this sum equals to the sum within the range of this, then it is true, else it is false. This is simple, but not yet. Why it is working? It is working because everything is a distinct number. Second thing, will this work for all the test cases? Might not. You see, I'll just reset this one. Yeah. You see, we are still within the integer range. Even if you code it within the long range, things are not very certain that you will not end up into the loop, because 1 plus 2 plus 3 up to so on till 99 becomes a very big number. Not a very big number, but a frequently good number. And if it certainly goes to 9999, then of course it is a big number then. So how can we deal in such cases? So we have a start, we have an end, but we need a new start, which would be start, or which I can say 1, because I wanted to start the counting from 1, because to keep the summation minimum, if I'm having something like start is 999 and end is 4 times 9. So in that case, this sum is too much long. If I can normalize it somehow, let's say start is equal to 1 and end is equal to whatever this number is, minus 999 plus 1, then the number resulting would be same. So it would be something like this, 0 0. Yeah, this is something what it looks like. The sum between start and end, now it looks same. But if we are normalizing start and end, we should also normalize the contents within the array, which we will do certainly. So new end, I would say, is end minus new start. End minus start plus 1. Now for each number n within the array, let's normalize this one. N is equal to, how we normalize this end? We normalize it by minusing with start and plus with 1. Same we will be doing here. For n, minusing with start, adding 1 to it. So this is a maths going on over here, bear with me. And now I just need to see that, hey, if 1 is less than or equal to n, and n is less than or equal to end, or I would say new end. That's a much more appropriate term. So if this is equal, or if this fits into the range, then we need to sum this up. So we'll have a sum which would be sum initially would be 0. I'll sum it up, I'll do it for all the numbers, and in the end I'll just check sum is equal to expected sum, and that's it. But wait a second, what is expected sum? So within the maths you have learned that sum of numbers from 1 to n is nothing but n into n plus 1 divided by 2. So it is the same over here. Now we have 1 to new end, so new end into new end plus 1 divided by 2. So this is a formula directly which comes out from arithmetic progression. And if I run this one, let's see what happens. Yeah, it passed for sample test case. Let me check for the rest of the test cases as well. And yeah, it passed successfully for all the rest of 4 times 1 test cases. So 1111. Nice number, by the way. So yeah, this categorized under basic, but again it can be an easy problem, easy medium problem. Definitely with not the constraint auxiliary space, it would be a very basic problem, right? As you can see, it was asked in Amazon and it carried a topic tag of data structure, algorithm, arrays and searching. Moreover, I found it more related to maths. Maybe I have looked it in that way. And yeah, that was all about it. If you wanted to see more such content, click the video on your right and I will see you in the next one.